Okay, number 37, we're asked to solve the trig equation 36. Sine of x is equal to negative 18 square root of 3. And we're going to start by dividing both sides by 36 to cancel out that coefficient on the sine function. And we'll have sine of x is equal to negative square root of 3 over 2 when we reduce the 18 over 36. Then we take the inverse of both sides, and sine inverse is the arc sine. Gets the x by itself on the left, and then on the right we're going to evaluate the arc sine of negative square root of 3 over 2. So the sine of square root of 3 over 2 is our reference angle, and that would be pi over 3. Right, the principal value would be negative pi over 3, but we're asked to find all solutions over the interval negative infinity to positive infinity. So we're going to start by finding our first non-negative answer from 0 to 2 pi. And sine is negative in quadrants 3 and 4. So quadrant 3, when we reflect pi over 3, we get 4 pi over 3. And then quadrant 4, when we reflect pi over 3 into quadrant 4, that's 5 pi over 3. And the period of sine is 2 pi. So we'll need two expressions to represent all of the solutions. So x equals 4 pi over 3 plus or minus k times the period, 2 pi. And for our quadrant 4 solutions, x equals 5 pi over 3 plus or minus k times the period, 2 pi. And those two expressions would represent all of the possible solutions from negative infinity to positive infinity. Okay, 38, we're going to solve in much the same way. So we have 3 cosine of x plus 4 equals 6. We want to isolate the x on one side of the equal sign. So we'll subtract this constant to the other side, and we get 3 cosine of x is equal to 2. Then we'll divide both sides by the coefficient, and that 3 then will cancel and leave us with cosine of x equals 2/3, and we take the arc cosine of both sides to get the x by itself then. So x is equal to the arc cosine of positive 2/3. In the calculator, we want to be in radian mode, which we are, and we'll evaluate the arc cosine of 2/3. That's a positive, so our principal value will come from quadrant 1, and that's 0.84. So x is approximately equal to 0.84 plus or minus k times the period in radians, and for cosine that's 2 pi. And that would represent our solutions that have their terminal side in quadrant 1. That's a terrible looking 8. Let's see if I can fix that. There we go. And then cosine is also positive, in quadrant 4. So we're going to take our principal value from quadrant 1, and reflect it into quadrant 4. So that's going to be 2 pi minus the principal value to get our solution in quadrant 4. So in the calculator, we'll evaluate 2 pi minus our principal value, and that's 5.44. Oh, that looks like a 9. It should be a 4. So 5.44 plus or minus k times the period, which is 2 pi. And that'll represent all of the solutions over the interval -infinity to infinity.